All right, everyone, ready to dive in? Today we're going deep on organoid intelligence.
ON.
OA, OI.
Yeah.
Yeah, where brain cells meet computer chips.
It's like something out of sci-fi, isn't it?
It really is, but it's actually happening right now.
Yeah.
We're talking about real science.
Real science.
And to guide us today, we have an interview with Brett Kagan, a neuroscientist who's at the forefront of this OI research. And he is just brilliant. You can tell he's really excited about the potential of OI.
Absolutely. And I think what struck me was not only the potential, but also his awareness of the challenges and the complexity of it all,
Yeah.
replicating even the most basic brain function. It's a huge undertaking.
Yeah, so think of this as like a crash course in organoid intelligence.
Exactly.
We're going to
Yeah.
break down what it is, how it works, and why it could actually revolutionize the world as we know it.
By the end of this deep dive, you'll know what OI is, what it can do, and what some of the hurdles are that researchers are facing.
Okay, so let's start with the basics. What exactly is organoid intelligence?
So imagine scientists growing these tiny 3D clusters of brain cells called organoids in a dish.
Like mini brains.
Mini brains, exactly. And these organoids, they actually have some of the functional properties of a real brain.
Wow.
They can learn and adapt.
Seriously?
And researchers like Kagan, they're connecting these mini brains to electronic circuits, basically creating this hybrid biocomputer.
Okay, so we've got these mini brains on a chip. What can they actually do?
Well, one of the most amazing demonstrations of OI was an experiment where they taught a network of these brain cells to play Pong.
Hold on, brain cells playing video games. How is that even
This
possible?
sounds wild, I know, but get this, these neurons learn to play Pong in just 5 minutes.
5 minutes.
5 minutes. It shows you how incredible the brain's natural learning ability is,
That's crazy fast.
right? Especially when you compare it to traditional AI.
Yeah, traditional AI takes like hours or even days to learn something like that.
Absolutely. This difference in learning speed is one of the things that has researchers so excited about the potential of OI.
So why even bother with growing brain cells when we already have AI? I mean, what's the big advantage of OI?
That's a great question, and Kagan addresses that directly. He says that brain cells are way more energy efficient than our current AI systems.
So it's all about efficiency.
Think about it. The human brain runs on roughly 20 watts of power.
That's it.
That's it. Now, compare that to the huge amount of energy used by data centers powering today's AI models, and you start to see the sustainability advantage of OI.
Okay, that makes sense. Less energy faster.
Sort
Learning
of.
OI is sounding pretty impressive.
It definitely has potential. Another area Kagan highlights is this idea of embodiment, which could be key to unlocking even more of OI's capabilities.
Embodiment. What does that even mean when we're talking about brain cells in a dish?
Imagine giving these brain cells a virtual body and a simulated environment
Okay.
so they can interact with objects, experience consequences, and learn through that interaction.
So it's not just input and output, like with regular AI.
Exactly. It's about allowing these neuron networks to really understand their world, making their learning more meaningful, more like how we learn in the real world.
Wow. Okay, so we've got these organoids learning super fast, potentially using way less energy, and now they have virtual bodies to experience their environment.
It's pretty mind-blowing.
What's next for OIY? What are researchers focused on now?
Well, one of the big things is developing hardware and software specifically designed for OI.
Right, because right now they're using what's already out there.
Exactly. They're having to kind of hack things together to make even basic experiments like the Pong game work.
So imagine what they could do with the right tools.
Exactly. That's where a lot of the research is focused right now, developing those tools and platforms that could really take OI to the next level.
What about scaling this up? Can we make these organoid brains bigger, more complex, handle tasks beyond playing Pong?
That is the million-dollar question, and it's one of the biggest challenges that researchers are facing right now.
Yeah.
Can we create OI systems that are intelligent, but also robust, reliable, and able to tackle more complex problems? It's still an open question.
So it seems like we're still in the early stages of figuring out what OI can really do.
We are, but that's also what makes this feel so exciting. We're on the cusp of a potential revolution in computing.
With any new technology, there are definitely hurdles to overcome, and a lot we still don't know.
Absolutely. But I think it's safe to say the future of OI is incredibly promising, and we're just scratching the surface.
We've covered the basics of what OI is and how it works, but what can we actually do with it? Where can we apply this technology?
Well, that's exactly what we're going to be talking about in part 2 of this deep dive.
Stay tuned. We'll be right back.
We'll delve into the potential applications of OI, from revolutionizing medicine to changing the way we think about computing itself.
Welcome back, everyone. So we're continuing our exploration of organoid intelligence, and this time we're looking at its potential applications, like where could OI make a real difference?
The potential is huge. It really spans fields like medicine computing, even how we understand consciousness itself.
So let's start with medicine. Kagan talked about drug discovery and disease modeling. How could OI have an impact there?
Well, imagine testing new drugs on actual human brain cells, but without the ethical concerns of human trials.
Okay.
OI could revolutionize drug development. It could give us a faster and more efficient way to find new treatments.
So speed things up and make it more effective.
Exactly. And because these organoids come from human cells, they could also provide a much more accurate model for studying diseases like Alzheimer's or Parkinson's.
So we could actually understand these diseases better.
Yes, potentially leading to new therapies.
That's incredible. It's like having a personalized testing ground for each patient.
Yeah, that's the ultimate goal. Personalized medicine tailored to an individual's genes, and OI could play a big role in making that happen.
So are we talking about curing diseases that are currently incurable?
It's possible, although OI is still in its early stages. A lot of research needs to be done before we see those kinds of breakthroughs.
But the potential is there.
Yeah.
What about applications beyond medicine? Kagan mentioned OI-powered prosthetics.
Now, that's one of the most fascinating applications, I think. Imagine a prosthetic arm controlled not by motors, but by your thoughts, seamlessly integrated with your nervous system.
That sounds straight out of science fiction.
It does, doesn't it?
Yeah.
But that's the potential of OI.
How would that even work?
It's all about creating a direct connection between the organoid and the nervous system. The organoid could learn to interpret brain signals and translate them into commands for the prosthetic limb.
So the organoid would be like a translator between your brain and the prosthetic.
That's a great way to put it. It's still experimental, but researchers are making progress in connecting organoids to peripheral nerves.
Wow, the possibilities are amazing. What about computing itself? Could OI change the way we think about computers?
That's what a lot of researchers are exploring.
Right.
Kagan talked about heterogeneous compute, combining different types of processing units.
So instead of just CPUs and GPUs, you'd have these biological processing units too, the organoids.
Exactly. Each type of unit has its own strengths and weaknesses. By combining them, you create a system that's more powerful than the sum of its parts.
So it's not about replacing our computers, but making them better with this new kind of biological intelligence.
That's the idea. We need to think of OI as complementary to what we already have. It's about expanding what computers can do.
Kagan also mentioned learning from OI to improve our understanding of how humans learn.
Right. By studying how organoids learn, we could gain insights into the basic principles of learning and intelligence that could then be applied to how we learn.
So we're not just building better computers, but understanding ourselves better.
Exactly. OI could revolutionize technology, but it could also deepen our understanding of who we are and how we think.
Okay, so we've talked about all these applications, but what are some of the challenges that stand in the way of OI becoming a reality?
One of the biggest is scalability. Can we actually grow these organoids to be big enough and complex enough to handle real-world tasks?
Right, playing Pong is one thing, but controlling a prosthetic or designing a new drug is a whole other level.
Exactly. Another challenge is robustness and reliability. Can we create OI systems that are stable and work consistently over time? Remember, these are biological systems. They can be quite fragile.
That makes sense. And what about the hardware and software? We talked about the limitations of existing technology. How are researchers dealing with that?
Well, there's a lot of work going on to develop specialized hardware and software that's designed specifically for OI.
Okay.
For example, new types of biocompatible electrodes and sensors that can interface with the organoids more effectively.
So it's about building an environment where these organoids can thrive and connect with our technology.
Exactly, bridging the gap between the biological and the digital. And that requires some really innovative engineering and a deep understanding of both biology and computer science.
It sounds like there's so much exciting research happening in the field of OI.
There is, and while there are definitely challenges, the potential is enormous.
Yeah.
This technology could transform medicine, reshape computing, and even change how we understand ourselves.
Okay, so we're back for the final part of our deep dive into organoid intelligence.
The home stretch.
We've covered the basics, the potential applications, and now it's time to talk about something really important, the future implications of this technology.
Yeah, things get a little more philosophical here.
It does. It's one thing to talk about brain cells playing Pong, but when we start talking about creating systems with real biological intelligence, it brings up some big questions about the future, for humanity and technology.
Absolutely. I mean, we're essentially talking about creating a new form of intelligence, right?
Exactly.
One that's based on biology, not just silicon and code.
Right. And that changes everything.
It really does.
Yeah.
It changes how we design computers, how we understand intelligence, even consciousness itself.
Exactly. It challenges our whole definition of what it means to be intelligent, to be sentient.
Right. If we can create systems that think like humans,
Mm.
at least in some ways, how do we define their rights? Do they deserve the same moral consideration as any other living being?
These are questions that philosophers have been debating forever.
Yeah, but OI brings a whole new dimension to the debate because we're not just theorizing about AI anymore. We're actually building it cell by cell.
And it's happening so fast. The advancements in OI research are incredible. It feels like every few months there's a new breakthrough.
Which is why it's so important to have these conversations now while the technology is still young. We have a chance to shape how OI develops, make sure it's used ethically.
Kagan himself talked about that a lot, the need for responsible development and open discussion between scientists, ethicists, and the public. He seems very aware of the potential risks and is pushing for a cautious approach.
I think that's crucial. We can't get so caught up in the excitement of new technology that we forget about the ethical implications.
It's like a tightrope walk.
It is. It's a balancing act, but an essential one.
So what does responsible development actually look like in this case? What are the key things to consider?
Well, for one, transparency, being open about the research, the methods, and the potential risks and benefits.
Yeah, so everyone knows what's going on.
Exactly. And ensuring that the research is done ethically.
Mhm.
Prioritizing the well-being of both the organoids and the people who might use this technology.
That makes sense. And having these discussions publicly, not just among scientists, but with policymakers, ethicists, and the general public.
Everyone has a stake in this OI, has the potential to affect all of us in profound ways. So we need to approach it with a sense of shared responsibility.
It's a societal issue, not just a scientific one.
Right. And we need to be asking some tough questions. What are the potential unintended consequences of creating systems with biological intelligence? How do we make sure this technology doesn't make existing inequalities worse or end up in the wrong hands?
There are no easy answers to these questions.
No, but at least we're acknowledging them and starting the conversation.
And it's not just about avoiding the risks, it's also about using OI for good. How can we use this technology to improve lives to solve some of the world's biggest problems?
That's where things get really exciting.
Ah.
I mean, think about it. OI could be used to develop new clean energy sources, to create sustainable materials, to enhance our cognitive abilities. The possibilities are endless.
It's about creating a better future, not just with technology, but also in terms of what it means to be human in a world where biological and artificial intelligence coexist.
That's a future I'm really looking forward to. It'll have challenges, of course, but also incredible possibilities, and it's a future that we get to shape together.
So as we wrap up this deep dive into organoid intelligence, I'm left with a feeling of awe and a sense of cautious optimism. This technology has the power to change everything.
It really does.
It's up to all of us to make sure it changes things for the better by asking the hard questions, having open conversations, and approaching this new frontier with a sense of responsibility and wonder.
I couldn't have said it better myself.
Thanks for joining us on this deep dive into organoid intelligence. It's a topic that's sure to keep evolving, so keep those questions coming, and let's continue exploring this incredible new frontier together.